Question overview. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Today we're solving a common networking challenge in Google Cloud. We have 3 VPCs with existing peering between VPC 1 and VPC 2, and we need to connect VM3 in VPC 3 to VM2 in VPC 2. The key constraint here is, without affecting existing resources. This means we can't modify the current peering between VPC 1 and VPC 2, and we need to maintain feasibility. This question tests your understanding of VPC networking options in GCP, particularly the limitations of VPC peering transitivity and alternative connectivity solutions. Let's analyze each option to find the best approach. Understanding the current setup. Before we dive into solutions, let's understand what we're working with. We have 3 VPCs in the same project, each with 2 subnets and 1 VM with private IPs only, no external IPs. The crucial detail is that VPC 1 and VPC 2 are already peered. In Google Cloud, VPC peering is non-transitive. This means even if VPC 1 peers with VPC 2, and VPC 2 peers with VPC 3, VPC 1 and VPC 3 cannot communicate through VPC 2. It's not a routing hub. This non-transitivity is by design for security and network isolation. It prevents unintended network exposure and maintains clear network boundaries. Our challenge is to connect VM3 to VM2 while respecting this architecture and the existing peering relationship. Option 1. Shrink subnet and create peering. The first option suggests shrinking subnet 11 to A25, from what we assume is a larger subnet, and then creating a peering between VPC 3 and VPC 2. Let's think about this carefully. Shrinking a subnet in GCP isn't straightforward. You can't actually shrink an existing subnet. You'd have to delete and recreate it, which would definitely affect existing resources. Any VMs in that subnet would lose connectivity. Even if we could shrink it, why would we? The subnet size has nothing to do with our ability to create a new peering connection. This seems to confuse subnet sizing with peering requirements. The second part, creating VPC peering between VPC 3 and VPC 2 is actually feasible and makes sense. But the subnet shrinking part makes this option incorrect as it would affect existing resources. Option 2. Network interface in VPC 3. This option suggests creating a network interface in VPC 3 and attaching it to VM2. This is an interesting approach, essentially making VM2 multi-homed with interfaces in both VPC 2 and VPC 3. However, there's a critical limitation in GCP. You can only add network interfaces to a VM instance when it's created. You cannot add additional network interfaces to an existing VM. To implement this, we need to delete VM2 and recreate it with multiple network interfaces. This clearly violates our requirement of not affecting existing resources. While multi-NIC VMs are a valid pattern for connecting VPCs, they require planning from the start. This option is not feasible given our constraints. Option 3. Cloud VPN solution. Now we're looking at Cloud VPN between VPC 2 and VPC 3, with subnet 32 advertised only on Cloud Router. This is a more complex but potentially viable solution. Cloud VPN creates encrypted tunnels between VPCs and can work even within the same project. Unlike peering, VPN connections can provide more granular routing control through Cloud Router's BGP advertisements. By advertising only subnet 32, where VM3 resides, on the Cloud Router, we ensure that only the necessary routes are exchanged. This maintains network segmentation and doesn't affect the existing VPC 1 VPC 2 peering. However, VPNs add complexity, potential latency, and additional costs. For intra-project connectivity, it's generally overkill when simpler solutions exist. But it is technically feasible. Option 4. Direct VPC peering. The fourth option is elegantly simple. Create VPC peering between VPC 3 and VPC 2. Let's examine why this might be the best approach. VPC peering is Google Cloud's preferred method for connecting VPCs. It provides line rate performance, no bandwidth charges for peered traffic, and is simple to set up and manage. Creating a new peering connection between VPC 3 and VPC 2 doesn't affect the existing VPC 1/VPC 2 peering. Each peering connection is independent. VPC 2 can have multiple peering connections. It's not limited to just one peer. This solution requires no changes to existing resources, provides optimal performance, and follows Google Cloud best practices. It's the simplest solution that meets all our requirements. Comparing all solutions. Let's compare all four options across multiple dimensions: feasibility, impact on existing resources, complexity, performance, and cost. Notice how option 4, direct VPC peering, scores highest across all important metrics. It's feasible, doesn't impact existing resources, is simple to implement, provides the best performance, and has no additional costs. Option 3, Cloud VPN, is technically feasible but adds unnecessary complexity for an intra-project connection. Options 1 and 2 both require modifications to existing resources, making them non-starters. In cloud architecture, the simplest solution that meets all requirements is usually the best. Don't over-engineer when a straightforward approach works perfectly. Understanding VPC peering mechanics. Let me explain how VPC peering will work in our scenario. When we create peering between VPC 3 and VPC 2, routes are automatically exchanged between these networks. VM3 in VPC 3 will be able to reach VM2 in VPC 2 using VM2's private IP address. The traffic flows directly through Google's network backbone, no internet traversal, no VPN overhead. Importantly, VM3 won't be able to reach VM1 in VPC 1, even though VPC 1 and VPC 2 are peered. This is the non-transitivity in action. Each peering connection is isolated. This isolation is actually a security feature. It ensures that network access is explicit and intentional, not accidentally inherited through chain connections. Implementation steps. Let me walk you through implementing the VPC peering solution. It's remarkably straightforward. Just a few gcloud commands or console clicks. First, we create the peering connection from VPC 3 to VPC 2. Note that peering must be established from both sides. It's a mutual agreement between VPCs. Then we create the reciprocal peering from VPC 2 to VPC 3. Once both sides are configured, routes are automatically exchanged and connectivity is established. The beauty of this solution is its simplicity. No firewall rules to modify, assuming default allow rules for internal traffic. No routing tables to update manually, no additional infrastructure to manage. It just works. Summary and best practices. To wrap up, the best solution is option 4. Create VPC network peering between VPC 3 and VPC 2. It's simple, efficient, and doesn't affect existing resources. Remember these key principles. VPC peering is non-transitive, meaning connections don't chain. Each VPC can have multiple peering connections. For intra-project connectivity, peering is usually preferable to VPN. When designing network architectures, always consider the simplest solution first. Complex solutions should only be used when simple ones don't meet your requirements. And always read the constraints carefully. Without affecting existing resources, immediately eliminated half our options. Understanding requirements is just as important as understanding the technology. Thank you for your attendance. Please consider subscribing to the channel and hitting the bell icon to get notified of new videos.